Hi everyone, so for today's classwork, I'm going to start. So the first thing I want you guys to do is to watch this video. Um, It'll kind of give you a little bit more of the background of what we're talking about with transformations and how it applies to congruency. So it's really important that first I want you to watch this video, then I want you to take notes on a separate sheet of paper, and you'll send me those notes so I can see that you watched it and you got something out of it. The classwork for today is a lot like yesterday. So the basics are the same. So make sure you do yesterday's classwork before you do today's. So let's see. Our instructions are for all these problems, 6 through 10, are to justify whether the triangles meet SAS congruence, explicitly state which pairs of sides or angles are congruent and why. If the triangles do meet the SAS congruent criteria, describe the rigid motions that would map one triangle onto the other. So I'm going to try and follow these instructions pretty closely in this video. I'm just going to do, today I'm going to do 7 and 8. So let's see. I'm going to grab 7 right here. Not quite. Let's try that again. There we go. All right. So, given that Jm is equal to KL, what does, now we have Jm, we got this symbol here, ML. What does this symbol here mean? It looks like this. Well, that wasn't great. Let's try that again. Looks like this. What this symbol means, kind of an upside down T, that means perpendicular. And perpendicular means that two things form a 90-degree angle. So if you look at the symbol itself, there would be a 90-degree angle here. So first off, let's start from the beginning. We got Jm is equal to KL. So this side matches KL, matches this side. So these are the same length. And what you'd make a 1 tick mark if you want to do it that way. I like to highlight with colors, just so you see it. Now, it also says that Jm and ML are perpendicular to each other. So let me switch colors here. I'll do it red. Jm and ML are perpendicular, so that means that there's a right angle here. Jm and ML are perpendicular, so this whole angle is 90 degrees. And that KL and ML, there's a 90 degrees, so KL and ML, there's a 90-degree angle. Do JML and KLM meet SAS criteria? So what I'm going to do is let's pick a color. I'm going to do green. Do one of the colors on the nice lime color. I'm going to make it thick. So JML, let's figure out what triangles we're talking about. We're trying this triangle, this triangle, this triangle, this triangle, or is there something else in here? So JML is basically this triangle. Now, is that triangle congruent? In green, so this is green. Is that triangle congruent to, let's pick another one. Let's just teal. To KLM. And KLM. So we're trying to say, is this blue triangle congruent to the green triangle? So what do we know? So going back over, we know that this side, you still see the purple there, this is equal to this. Let's try and make sure I make that clear. Purple, that this is equal to this. This side equals this side. What else do we have here? You see how the green and the green and the blue overlap here? That means that's a shared side. So that means that this side is equivalent for both triangles. So we got a side here, and we also have a right angle here. So this is 90 degrees, this is 90 degrees. So let's think about that. And I'll highlight it over it in red again. this angle is equal to this angle. So we got basically side, angle, side, side, angle, side. So for this one, yeah, it works. We got SAS. So I'm going to say SAS, we got, so yes, they're congruent. Another thing to see is what the problem said. I feel a little bad, I didn't really do this on the last video. Justify whether triangles meet SAS congruence criteria. Explicitly state which pairs of sides or angles are congruent and why. So I'm going to do that real quick. So let's see. That's not it. Okay. There we go. So the congruent sides are, we know that JM, so let's just go through it. We know we need the SAS thing. So what SAS means that SAS on one triangle is congruent to side angle side on the other triangle. So I'm just going to list them out. We know that JM is equal to KL. And they actually gave us that, but let's just copy it down. JM equals KL. And we'll just say, because it's a side, I'm gonna put a little line above it. Not always necessary. The other thing is that ML is the same on both. So I'm going to say ML is equal to LM. So these two sides are also the same. So ML is the same as ML. That makes sense. Or ML is equal to LM. And because the other thing is the angles that are the same, the measure of angle, let's out the angles out fully. So JML. So JML. And I don't want to run into my face here, so I'm going to say is congruent to. Actually, all I'm saying is I'm putting all these equals here, but I forgot. You can also say that the sides are congruent themselves. I'm add a little squiggle on top. Essentially means the same thing. And that JML is the same as KLM. KLM. And this is what you have to do to like fully answer that problem. But the main thing is that yes, it's SAS. This side equals this side. This side equals this side. This angle equals this angle. And that's where the SAS comes from. So, yeah, we answered this problem. So, let's see. I'm going to do the next one. And then I'll leave you guys to do the rest. So, for this one, number 8. Let me just grab it real quick. Okay. So, given that BF is, what does this sign, this little thing mean here? That means perpendicular. Given that BF is perpendicular to AC, so BF is perpendicular to AC, that means that there's a right angle here and a right angle here. And CE is perpendicular to AB, so CE is perpendicular to AB. That means there's a right angle here, there's a right angle here. Does BED, or do at this triangle, I think it should be does triangle BED and triangle CFD meet the SAS criteria? So let's see. Let me switch colors a little bit. Green, and this is too thick. There we go. So BED, that is BED, so that's right here. So what I'm highlighting here in green, does this triangle, BED, is that congruent to, let's pick another color, to CFD. CFD. So does this triangle here in blue match the triangle in green? Well, we know that this is a 90-degree angle, so that helps. Do we know anything about the sides? They didn't really tell us anything else. So, you know, like, maybe if they had said that, I don't know, these triangles they bisected each other. That would help. But they didn't say that. So we don't know that this is a midpoint. They didn't say this big triangle up here, maybe it was like this is equal to this. They didn't say that. So I think for this one, they didn't give us enough information. So we're going to say no. For this one, we don't have enough information. We know that this angle equals this angle. We actually also know, there's one thing I forgot to say. We do know that, that'll do. We do know that this angle here has to equal this angle here. So we got two angles. When you have an angle, you have a third angle. Because basically all angles have to add up to 180, so you can always find the other one. So when you do this angle and this angle, we know this angle must match this angle by that. So the triangles, all the angles match, but remember that AAA, that's not a congruence criterion. It is a criterion for similarity, so we know that these two triangles are similar. Similar just means that they're the same shape, but we don't know that they're the same size. So that's pretty much all we have for this one. So we're going to say no to the question that, when it asked, justify whether the triangles meet SAS congruence criteria. They don't. So we can't really say why if they don't. Well, we know why they don't, but because they didn't give us enough information. So we're going to say no, and we're going to say no. Actually, let me pull that up. No. You can say not enough information. So I actually did prove, well, I didn't really prove it mathematically, but I did show you that these two triangles, BED and CFD, they're similar, so they're the same shape, but I wasn't able to show you that they're the same size mathematically. So that's all I'm going to go over for this one. I did 7 and 8. I want you guys to do 6, 9, and 10 on your own. And just let me know if you need any help with that.